I'm Dr. Melanie Windridge, a physicist and mountaineer. I'm climbing Everest and I want to highlight the science that gets us to the summit. Oxygen is hugely important to safety on Everest. So I'm here at the Royal Geographical Society to see the oxygen sets that were taken up in the expedition in 1953. And I'm going to talk to Neil Greenwood of Summit Oxygen about the oxygen sets that are currently in use on the mountain. I can't believe that we're actually seeing the oxygen system from the first ascent of Everest in 1953. How have things changed to what we're using now on the mountain?
This system is a complete system. So it contains 2 cylinders, it contains all the regulators, the delivery mechanism and the face mask. It's heavier. Also, it has the problem when one cylinder runs out, you then got to switch to the other cylinder, and to try and replace one is quite hard work, it's quite a lot of effort. Each cylinder contains quite a heavy regulator, so you're carrying 2 of those parts when on a modern system we would only have 1 regulator which is interchangeable between a cylinder. So if we look at the components of a modern system, a modern constructed cylinder, so a climber could carry 1 or a number of these, or they could be pre-positioned on a route. It comes with a detachable regulator, significantly smaller and lighter than regulators in the past. That would attach to the cylinder. And then in addition to that, you've got a more modern design face mask. So it has the benefit of having a reservoir on the sides.
So does this reservoir here, that improves the efficiency of the mask because it stops oxygen being wasted when the climber breathes out?
Yeah, that's correct. So as I breathe in, you'll see that reservoir collapse. And then obviously if oxygen was flowing, that reservoir would then re-inflate during the exhalation phase.
So these developments on the mask have improved the system in terms of efficiency, and the developments on the cylinder and the regulators have made the whole system lighter.
Yeah, that's correct.
Are there any other improvements that have been made?
So what we've done is we've taken what was originally a Russian concept, a valve like this that only opens when you attach the regulator. Then the regulator also is detachable. That can be protected during the ascent and descent when it's not being used, and the same with the face mask. So there were a couple of problems with the Russian equipment. If you want to look at the face mask, for example, this was one of the Zvezda or Poisk face masks.
So when would this have been used?
I think their system came out about 1982, 1984, something like that. And this is a big improvement on 1953. You can see the oxygen delivery hose here. Oxygen would come up here, and the plan is that it goes down into a reservoir in here, and that reservoir, so inside there is a rubber bag, that would expand as the gas is flowing, and then when somebody breathes out, they're breathing out through the front of the mask.
Do they have problems with it freezing up as well when they're high?
Yeah, that's right. What happens is that as you breathe out, some of your breath is coming backwards in this direction, back into the reservoir. That ice will just build up and up and up until it becomes blocked. So there was often lots of cases where the gas pathway would get blocked. Gas is obviously still flowing into the reservoir, but it can't get into the mask, and these reservoirs would explode in some extreme cases. But also a lot of build-up of ice on the front of the mask where moisture was coming out from the breath, and that wasn't controlled particularly well.
Can you explain some of the developments that were made?
The main focus was making sure that the valves did what they were supposed to do. These 2 valves, so the ambient air valve and the oxygen valve, are weighted, so the resistance required to open the oxygen valve is very much slightly lighter than the resistance required to open the ambient air valve. That means that you get the oxygen before you get the atmosphere coming into the mask.
I suppose that's really important because they want to get the oxygen in first. On the mountain, above 7,000 metres, our oxygen systems not only prevented us succumbing to life-threatening altitude sickness, they also improved performance. With the help of oxygen, we could move faster, allowing us to spend less time in the death zone.
This is our first trial of oxygen at Camp 3. I was getting a headache from the altitude, I think, so we decided to start breathing some oxygen. It's only a little bit at the moment, but hopefully it'll help us feel better.
Oxygen at altitude is not like scuba tanks while diving. You won't die if you take off your oxygen mask for a while. You'll just be a bit out of breath. Altitude sickness usually takes several hours to develop. I'm at the South Col.
It's windy. We walked up from 3 today with oxygen. As you can see, I'm not wearing the oxygen mask at the moment, so I'm getting a bit out of breath. But it's lovely to be up here. That's the route. That's the way we're going in the morning. One more day above.
Women particularly benefit from oxygen because they are smaller. Their lower body weight means that the same amount of oxygen has a greater effect than on larger males. Despite being slower than my male teammates lower down, on summit day I reached the top first and was able to enjoy sunrise with just my Sherpa, Tenzing.
Hey, Everest. Please, we made it here for sunrise.
Are there any other places where people might use these kind of oxygen systems?
Anybody going to high altitude really, so we now have branched out into parachuting systems. Somebody jumping that has an aspiration to jump from say 35,000 feet and deploy the canopy straight away will spend a long time up in the air, so they need a system that's going to give them very, very good endurance.
Oxygen systems now are smaller, lighter and a bit more comfortable than they used to be. These developments mean that climbers get more benefit from the oxygen they're carrying, so they can perform better and will be safer on the mountain.